Hi, in this video we're going to talk about the mathematical idea of a function. It's something that we're going to use repeatedly throughout the semester. Algebra 2 is a course about relationships, and functions will give us a framework for talking about these relationships. So actually before we start talking about functions, I'm going to talk about the idea of a relation. A relation in mathematics is any way of connecting some inputs to outputs. In more formal language, we're going to use the terms domain and range. All right, but you can informally think of domain is the inputs and range are the outputs. Now, a relation is anything that connects the inputs to the outputs. So here I've drawn a diagram to kind of give you a visual idea of what a function or relation is. So here we have all the inputs. We have 1 in the domain and it's connected to 1 in the range. We can look at 4 in the domain and it's connected to 3 in the range. Now, a function is a specific type of relation. Here I have the very formal kind of definition. A relation is a function if every element in the domain corresponds with exactly one element in the range. So I take any one of these things, say 3, and there's only one thing it goes to. Now, example, it doesn't have to be like that. For example, I could have a relation that looks like that. That 5, one of our inputs, goes to 2 different things in the output or the range. 5 here goes to 3 and it goes to 5. So if you're doing this, you might have to make a choice or you might have to give both back, right? But if that red line's there, this is not a function. The informal way of thinking what a function is that every single input has only one output. So if I take away this red line, erase that. Once I take that away, every single input has only one arrow that goes to something in the range. So here then would be an example of a function. Right? Now there are lots of different ways of representing functions. One of them is just to have a diagram. We can just have some pictures and draw the lines and draw the arrows. Or we can have a bunch of different ways of setting up those rules. And those rules that we're going to use this year are the ones that you've used in mathematics for the last several years. All right, let's get to some examples. First example, we're going to define our relation based on just a set of ordered pairs. Here we have 3 different ordered pairs. Now normally you think about the very first one as the x-coordinate and the second one as the y-coordinate. We're going to continue to follow that convention, which here would make the x's, or the first ones, the inputs, and then the second coordinate is going to be the outputs, or the y-coordinate here. Right. And then our question here is this a function, this set of 3 points? To do that, we'll have to check the definition. We'll use the informal one here. Does every input have exactly one output? Well, let's see. If I look here, I have the input of 1, and this has an output of 3. This one has input of 5 and an output of 6. The next one, an input of 4 and an output of 11. It's a pretty small one, but every single input has only one output, which means this is a function. Right. So it is a function because every input has only one output. All right. Second example shows another way of representing functions, which is as graphs. Okay, here, again, we're going to think of the x's as the inputs and the y's as the outputs. So then our question, whether this is a function or not, is going to make us interpret the graph and figure out, is there any input that has more than one output? All right. Now, the x's, so our inputs, are on the horizontal axis. And we have to look at that to see, well, how many outputs does each one have here? I can look at this point right here, right where it crosses the x-axis, and say, hey, what's the input there? What's the output? Well, I see there's input here, and then the output, well, is just actually 0 for y, since it hasn't gone up or gone. So that place has just one output. But if I choose, say, right there, all right, I can look at going that much over on the x-axis and say, okay, that's my input. How many outputs does that have? So we look on the entire graph for, okay, when you go that far away from the origin horizontally, how many different things, how many different y's match up with that? And we have 2 here. We have the points here. And we don't have axes here, so, or tick marks, so maybe this is, I'll just guess here, maybe that's 2, -2. Maybe this one up here looks a little bit higher. Maybe that's 2, 4. Okay. And now here you can see, well, we have an input of 2 that has an output of -2. We have an input of 2 that has an output of 4. That means that one input has 2 different outputs, which makes this not a function. One other thing you might notice is that just because you're given one representation of function does not mean that you cannot interpret another. With the graph here, we basically took it, we turned some of these things into ordered pairs, we were able to think about it that way. And it's a very common thing that we'll do in this course and in all mathematics, is that just because you're given one representation does not mean that that's the one you have to stick with. Sometimes changing the forms will help you solve your problem or answer your question a little more clearly. All right. Moving on to example 3, here we have another very common way of expressing functions and relationships. This is equation. So y equals 2x plus 1, and here we'll determine, is this a function? Just like 1 and 2, we're going to interpret the x's as the inputs and the y's as the outputs. Now, figuring out whether this is actually a function requires some thinking. Okay? We could have a couple different ways of answering this question. One, we could graph this equation and then interpret the graph. We could also make a huge table of points and see if that gives us any wisdom whether this is a function. But I would rather just think about what it means to be an equation, and with this example, does that make this one a function? All right. I'm going to start off by just plugging a number in to get the idea of how these work in. So if I pick x equals 5, I want to find what y goes with that. What output would go with the input of 5? Well, I'd plug 5 right here. 2 times 5 is 10. 10 plus 1 is 11. So this would go with y equals 11. Yeah. I could do that for an infinite number of points. It wouldn't tell me much. But what I want you to notice there is that you didn't have any choice with how you got your y. As soon as you picked your x, in this case 5, I multiply that by 2, I add 1, and then I get my output. And since it's that very specific set of instructions and it never ends up with more than one answer, or makes me choose between a few different answers, that must mean that every single input only has one output. And that means that this one is also a function. Our last example, example number 4 here, is going to give us our relationship in a different way. This one's going to be a table. So here we have 5 examples of inputs, and each of them has a corresponding output. This is very similar to showing our data with a list of points. We've just written them a bit differently, but essentially they gave us the exact same information. So here, again, if we're to see if this is a function, we're looking for, do any inputs have more than one output? 0 has the output of 3, and there are no other zeros as inputs, so that one is just okay. We look here, we have 1 as an input, and we have 1 as the output. And if we look over here, well, we also have 1 as an input here, and it has 10 as an output, which is different. Let's circle these guys. Right. And we don't even need to look at the rest of the table here. I can tell from this point that there is one input, the number 1, which is associated with 2 different outputs, both 1 and 10. And that makes this one not a function. Right. To summarize functions and how we're going to use them this year, is they are a way of expressing relationships and working with them mathematically. Another nice part about them is that they focus on interpreting these relationships in terms of input and in terms of output. Right? And a relation is a function only if every single input has exactly one output.